Today we're going to be working on segment lengths. So last class we actually talked about doing angles, but now we're going to be given the same exact pictures, but we'll be determining how long these segments are. So for example, if you look in type 1, we have a bunch of intersecting chords. One thing that you'll need to be aware of is that the segment A plus B is not necessarily the same size as the segment C plus D. So there are going to be different methods for us to determine how long these things are. So when you're looking at one like type 1, where you have intersecting chords and there is no outside parts, what you're going to do is you're going to do part times part, so A times B equals C times D. So you'll take each part from the segment and multiply those together. So A and B are on the same segment, so you do A times B, and C and D are on the same segment, so you do C times D. Now, when we're looking at type 2, so type 2 has each segment where part of that segment is inside the circle and part of it is out. So there's a new formula for that one. So the formula is A times A plus B and C times C plus D. Those are going to be set equal to each other. So really what you're doing is outside, so the outside piece times the whole thing you add, A plus B, and then the outside times the whole thing, which is C plus D. When we're talking about type 3 actually does follow the same model as type 2, except for one of your segments doesn't have an outside and inside part. Therefore, what you're going to do is do A squared, which is really just your outside times your whole, because your outside and your whole are exactly the same. And then you're going to follow the same process of B times B plus C. So I wrote it out in words for you all so that hopefully we can remember it. So in type 1, what you're really doing is doing part times part equals part times part. And then in type 2, what you're doing is you're going through and doing outside times whole equals outside times whole. Just be very careful when we're talking about the whole here that we're adding the two pieces. So A plus B and C plus D when we're talking about the whole. Now for this one, we have outside times whole equals outside times whole, which is the exact same one as type 2. But I noted that for segment A, the outside and the whole are the same. So that's why we're going to do A times A, or A squared. And remember, you can always pause this at any time when you need to go through and write things down. So what I did was at the beginning of every single problem in our practice, I went through and I wrote down what formula you should be using. So number 1, we're going to use part times part equals part times part. So see if you can set that up. Alright, so what we should be doing is going through and we have 14 times 15, because they're part of the same segment, equals 10 times x. Now we'll solve it. We get 210 actually. 210 equals 10x. And then when we solve that, we get 21. X equals 21. Apparently Miss Bean doesn't know what 14 times 15 is. Now when you go to the second one, we have the same exact process here. So with the same exact process, we're going to do part times part equals part times part. So that's going to give us 18 times 2x minus 5 equals 14 times 2x plus 1. Now you just need to recall that when we're doing these sorts of problems, when you're set up like that, you're going to need to use the distributive property. So we should get 36x minus 90 equals 28x plus 14. Now we're going to need to go through and solve that, so hopefully if you take a second you can go through and solve that by yourself. So we should get 8x equals 104 and then x equals 13. Now you need to pay very careful attention because it asks you for RS. So you want R all the way to S. So you need to be very careful when you're doing this because you have two parts that make up RS. So you're going to need to plug in, and then the most important thing is to make sure that you add those two values. So it should look like this. 2 times 13 minus 5, that's plugging in 13 to the first section, and then adding the 2 together. So that gets you 21, so you do 21 plus 18, which gets you 39. So RS is 39. Now I wrote you a hint. It says when looking for the length of the entire segment, you must add the 2 pieces together. And I'm hoping you can remember what postulate that is. It's the segment addition postulate. Always pause if you're still writing. So in number 3 you're going through and you're also doing part times part equals part times part. So this time when you go through and do this, you're going to have to think a little bit harder. So the main issue with this one, or not issue, but a really big important step is that you're going to go through and do part times part equals part times part. So notice when that happens. Let me fix that real quick. Notice when that happens, you're going to distribute on the left side x times x minus 6, but on the right side, this is something back from Algebra 1. So what you're going to have to do in this one is you're going to have to FOIL, or you can use a box. We'll discuss it in class, but foiling or using a box means that you have to do x times x times negative 7, 2 times x, and 2 times negative 7. So once we've distributed correctly, we get x squared minus 6x on the left side. Remember, x times x gets you x squared, equals x squared plus 2x minus 7x minus 14. Now, I'm going to simplify the right side, and positive 2x minus 7x gets you negative 5x. Now, something that you should be able to solve for yourself is actually subtracting x squared from both sides, which gets them all to go away, so there are no more x squareds, lucky for us. And you get negative x equals negative 14. You might take an extra step in between, which is totally fine. And then you're going to divide by negative 1, and you'll get x equals 14. I will tell you that this type of problem will probably not be on your quiz, but you should be aware of how this works, and you should be able to complete it just in case it shows up on a test. Now, for number 4, it says solve for x. We're still going to use outside times whole equals outside times whole, because this one is a different type of problem than number 3. Number 3 has intersecting chords, and you have all insides, so you do part times part. For number 4, you have an outside and an inside. So you're going to do outside times whole equals outside times whole. So that gives us 9 times x plus 9. Remember, we add those. 9 times x plus 9 equals 8 times 8 plus 19. You can originally go through and say 8 plus 19 is 27 and start right there. But I went through and showed you what that was made up of. So I simplified that, and you get 9x plus 81 using the distributive property equals 8 times 27. Then you get 9x plus 81 equals 216, and you should be able to solve that from there. I'll give you a second to do so. And you end up with 9x equals 135, and then you have x equals 15. Now for number 5, we have outside pieces and inside, so we're going to do the same process, outside times whole equals outside times whole. So that's going to give us 12 times x plus 8 plus 12 equals 15 times x minus 1 plus 15. Now, you'll notice that the things inside the parentheses can be simplified, and you can do that right off the bat if you'd like to, or you can go through and write this step and then combine them. So you should get 12 times x plus 20 equals 15 times x plus 14. Now we're going to use the distributive property, meaning we have 12x plus 240, and then we're going to get 15x plus 210. Now solving this should be simple, so take a second to do so. 30 equals 3x, and x equals 10. Now it asks you to find xz. So if you'll notice, xz is 15 and x minus 1. So I put 15 plus x minus 1, and then I plugged in 10, and I got xz equals 24. Remember, you can pause if you need to. Now in number 6, we're going to do the same process. Outside times whole equals outside times whole. This one is slightly different than number 5 because we have, in PM, we have 8 and 5x minus 1, meaning we have an out and we have an in, but in LM we do not have that. So we're going to have to use 16 twice. So we get 8 times 8 plus 5x minus 1, that's outside times the whole, equals 16 times 16, because 16 is both the outside and the whole. Now we'll combine like terms, and we'll get 8 times 5x plus 7 equals 16 times 16, and then we go through and solve. So we distribute and multiply, subtract, divide. Now notice that in this one they ask you for Pn. So Pn, all we have to do is plug in 5. So 5 times 5 minus 1 gets you Pn being 24. Now let's look at number 7. So number 7 is exactly like number 6, just a slightly more difficult process. Actually, it's probably about the same. So we'll do outside times whole equals outside times whole. Here we have a segment with 9 and 16 having an outside and a whole. But 3x is both the outside and the whole. So we have 9 times 9 plus 16, and then 3x times 3x. Or you could do 3x in parentheses squared. Just make sure you use parentheses there. Which gives us 9 times 25 equals 9x squared. Multiply that out, and then divide it by 9. We're going to need to square root here, so square root on both sides, and that should get you x equals 5. Now number 8, I'm going to use the same exact process. So number 8, we're going to go through and we'll say outside times whole equals outside times whole. So what we'll see is we have 27 times 21 plus 27 and x times x. Multiply those out and you get, or add them, and then we'll multiply. We get 1,296 equals x squared. Now we're going to take the square root of that. Now it's always good to check in your calculator and see if it is a perfect square. And this one happens to be so just go ahead and put the square root of 1,296. And that's going to get us 36. Now, when we're looking at this one, so I'm going to take this over to the side because we don't know this yet. So we're going to start off by finding x. So when you find x, you're looking at just the interior segments here because that's where x exists. So we're going to do part times part equals part times part. That's going to get us 12 times x equals 8 times 18, which is 12x equals 144. That's going to get us x equals 12. Now we want to be able to find y. So in order to find y, we're going to go through and plug 12 where x used to be. So I'm just going to put 12 right here because that's where it belongs. We'll do outside times whole equals outside times whole. So because we have an outside with our 2, so 2 times the whole, which is 2 plus 12 plus 12. And then on our other side, our outside and our whole are the same, so it's y times y. That's going to give us 2 times 26 equals y squared. 52 equals y squared. Now we're going to square root 52, and we have to actually go through and make a factor tree, unless your teacher is okay with decimals. I usually do my factor tree. So if I do my factor tree, I end up with a pair of 2's and then a 13. So my answer is 2 square root 13. Now, number 10 is going to be the same exact process. Just make sure, I know that I forgot to change it, but I have an 8 up at the top and a y down at the bottom. I think mine are switched, but some may have fixed that already. Just make sure yours matches what the question says. So we're going to do part times part equals part times part. That gives us 3 times 14 equals 6 times x. Then we're going to go through and solve it. So that should be simple solving. 42 equals 6x, x equals 7. Now finding y is going to be the same process from number 9. Outside times whole equals outside times whole. So we're going to put 6 where x used to be. So now we have 8 times 8 plus, oops, that's supposed to be a 7. There we go. Wow, that's huge. Let's fix that. So now that we have that, we're going to do 8 plus 7 plus 6. Then we have 8 times 21 equals y squared. That's going to get us 168 equals y squared. Then you're going to need to square root that equation again. When you square root, you get quite a long factor tree, and you're actually going to end up getting 2 square root 42. That's all for this video. If you guys need help, you need to make sure to come in and get help either before or after school. Just make sure to talk to your teacher, as we'll have a quiz next class.